Hello everyone, welcome to EnggClasses YouTube channel for a video lecture series on digital signal processing. In this video we'll consider the concept of digital signal processor based on the Harvard architecture. The Harvard architecture was originally invented to increase the execution speed. How we'll see it later. Earlier computers used to store the instructions on punched tape and data using relay latches. Harvard architecture was built by IBM in the year 1944 at Harvard University. And today's Harvard architecture looks something like this. How does it look? So let's consider the picture of Harvard architecture. Once I consider the Harvard architecture, we must remember that it consists of five building blocks. Which are those? First is address generator, then there is something called program unit, and then there is input output devices, arithmetic logic unit abbreviated as ALU, and then we have got program memory and data memory. These two building blocks are very important. We have got separate program memory and data memory, which is the highlight of Harvard architecture. In case of Von-Neuman architecture, we used to have only one memory, and here we have got two memory spaces, one separately for the program and one separately for the data. And the next building block is multiplier and accumulator, famously called as the MAC. And then we have got a shift unit. As we have got program memory and data memory separately, and we have got associated with separate address buses. We have got two address buses for memory and two address buses for data memory. Yes, this is how it looks like, and this is the connection of all the building blocks to the address bus. If we consider the highlights of Harvard architecture, as I already said, there are two memory spaces, one completely dedicated for the program code and another for the data to be executed. And to accommodate these two memory spaces, there are two address buses and there are two data buses separately. Hence, Harvard processors can fetch program instructions and data in parallel at the same time. So this is very important. While it is executing the current instruction, it can fetch the data from the next instruction. So that is very important, and that these two instructions can happen parallelly. And if I consider MAC, that is the multiplier and accumulator, it is used in digital filtering operation. And there was something called shift init. Shift init, the importance of that is it is used for scaling operation for fixed point implementation. Whenever I'm dealing with fixed point implementation, the scaling may happen. Scaling in the sense the overflow may happen. So to tackle that, we have got shift init. Continuing further, so if I want to say how does the processing speed is increased in case of digital signal processor based on Harvard architecture, the answer is pipelining. In the sense, the digital signal processor performs one execution cycle while also fetching the next instruction to be executed. So what do you mean by that? Say for example, I'm working on the current instruction and I can also fetch the next instruction. So how if I want to show it in a picture, this is how it looks like in terms of execution cycle and fetch cycle. You can see that fetch and execution are overlapped in the sense, as the processor is executing the current instruction, it can fetch the instruction from the next cycle. So that's what the pipelining is. So moving further, if I consider the application, so where do I use hardware architecture? It is mainly on all the digital signal processor. As it is said, the Harvard architecture is preferred for all digital signal processors. Why is that? Due to the requirement of most DSP algorithms, such as we have to perform filtering, convolution, FFT. We all know that. Throughout digital signal processing course, we have done these courses. We have done these concepts: filtering, convolution, FFT. So how do I perform these things? I should have a dedicated digital signal processor. Why is that? Because all these things need repetitive arithmetic operations, including multiplications, additions. We have seen in circular convolution, linear convolution, filtering, overlap, add method, overlap, save method, that we have to perform repetitive additions, multiplications. Hence I use a Harvard architecture, and I need to access the memory, and I need to flow through the heavy data through the CPU. Hence I must make use of digital signal processor. All digital signal processors make use of Harvard architecture. So these are the applications, and this is the explanation for Harvard architecture. I hope you people have understood. If there are any doubts, please let me know them onto the comment section. I would definitely address those doubts. Meanwhile, subscribe to our channel NG Classes for more videos on digital signal processing. Till then, thank you everyone for watching.